let's start with our classic package. Raw Assert CTS group 1099 1091. Okay, seminar 6. So we are in week 6, and we will add the student class that you have seen yesterday at the course. And yesterday was just a base for the general discussion, and now today we want to unit test it by using right-BICEP and CORRECT principles. So we will define a name for a student, age, and the array list of grades. Just a moment. Okay. So array list, no, not this one. Array list integer with capital I. Okay, so this is called grades. Grades. Okay, we need to import Java util. And now let's generate the constructor because we will test it. And after that, let's generate some getter and setters, and we will write a dummy or fake method for computing the student average. The focus today being on unit test, it's okay to have methods which will generally do nothing because the unit test will fail, and in this way, we once again see the TDD philosophy, okay? Write unit test, and after that, implement the method, so make the tests go on green or be successful after you change the method. Okay, so right-click source, generate constructor using fields, all of them. And because here we have a shallow copy, that will be perfect for a test, for a reference unit test. Okay, remember from correct. Okay, and now let's generate the getter and setters. Now here for getter and setters, choose all methods for age. Okay, which means get and set. For name, the same. Name, get name, set name. And for grades, let's check only set grades. Okay, because generally we don't want to expose a reference from our object, because anyone who will get that reference will have full access on those values. So I don't want to give you the entire array of the student grades. Maybe I will give you particular grades, and for that we will write our own get methods, which are very simple to implement. Okay, so we selected all the methods for age, name, and for grades only set, and we hit generate. And now for grades, like I said, let's implement our own get methods like this. So public int get number of grades. I need this method in order to query how many grades a student has. So return this grades size. Okay, and public int get grade. Okay, and get grade will return a grade for a given index. And once again, all these methods are implemented without validations. We don't, let's say, try to think before the unit tests, okay? We will just make very simple implementations, and the unit test will show us that we have a lot of things which are missing, okay? That's why I'm not validating yet anything. So here will be return these grades, get index. Okay, so we have two methods that will allow us to see grades from the student and without actually giving the reference to the entire array list. And the last method is dummy or a fake method for computing the grades average We discussed about this, I think, last week, but now I want to get grades mean 2 decimals. So I want to compute it as we are using it in our systems, okay? Because all your means for or averages for your grades are always processed with 2 decimals, okay? And here I'll just do a return 0 for the moment. Obviously, any unit test will fail on this method because we don't have a real implementation. It's just a fake. It has the signature, but it's returning 0. Okay, so this is the base class for today unit tests. Now, I will try to do this as much as I can. So I will upload on Git. If you somehow didn't manage to write this initial class, I will upload it right now on Git. So you can copy it if you missed some functions or you don't have the method, because the class. We need the class in order to do the unit test. We can't get around it. So just a moment, I will just update it. Okay, and it will be available now. So if you check Git or refresh the repository for our seminar, you will find the seminar 6 and you will have this class. So you can copy it and use it along this seminar. Okay, now let's write the specifications. So we need the specifications regarding what are correct values for us. Okay, remember we did this analysis yesterday when we covered range, for example, the range principle. So we need to define our own limitations here, okay? And obviously I will write some comments like this. So let's establish that age is in this interval 1490. We used these values yesterday. Name should be, name size is between, is at least, let's say, at least 3 chars, but no more than 255, because we have a limitation given by our database. And grade, each grade is in 110. Okay, now how do we define this in order to use them? These limits, if we hard code them in our source code, once again, we will see a lot of numbers in many of our functions, because the programmer, and in this case us, we will check against 110 each time we receive a grade, or between against 14 and 90 when we try to change the age. So we will see a lot of numbers. So maybe later these limits will change. And also when you write unit tests, you need these values. So the conclusion was that we try to avoid, or we will remove numbers from our functions because they are hard to read. In 1 month, you will forget what's 14 and 90 or 1 and 10. So we replace them by public, static, and constant variables. That's why we define them public, because being constant, no one can change them. So we will allow anyone to read them, but they can't change them. So public, static, final, and this will be the minimum age, mean age, okay, equals 14. Public static final int max age equals 90. Public static final int mean grade equals 1. Public static final max grade equals 10. And for the name, public static final int min name size equals 3, and we can copy this line. Now, obviously, based on clean code, you may now say that we have a problem here. We have a lot of static values here, so it's increasing the complexity of the student class. And if you have a, let's say, bad smell feeling, which means this is slowly going to a smelling code, because we have all these attributes here. Static, yes, the feeling is right. So generally, these values should be removed out of the class, because let's say these are defined by logic restrictions. So you can define an interface, because in an interface you can define all these attributes and we can implement that interface. Okay, so in this way we can change the limits easily. Okay, but for this example, let's ignore this problem. So, and here is 255. Okay. Now, if at any moment my microphone will be interrupted, just write on chat window. Okay, so give me a buzz or raise your hand. Like I said, sometimes I have issues with the microphone. Okay, so we have the limits, we have the class. Let's write the unit tests. And also, we discussed yesterday that for any value which is not conformant, remember conformance, or it's not right, or you have the criteria that says always false error conditions, we established that in those cases, when the input values are not right, when the function can't process and it can't deliver the promised value, the result, we will always announce this situation by throwing an exception. So we need a custom exception. Okay, let's define a package for that. Exceptions. So in here we will define all our exceptions, and let's add. It's very cheap to define your own exceptions. It's like you need only 1 minute. So they have more advantages if you are using custom specific exceptions rather than using a single one generic exception. So we will define let's say student bad value exam bad value exception just to have an exception that will cover most of the cases for a student. So extends exception. Okay, and regarding what I just told you, that there are more advantages in defining your own small framework or of custom exceptions. Let's give a particular one. So let's say student wrong age value exception. So this will be a custom, a specific exception that we will throw each time someone is trying to give us a wrong value for age, which means out of 1490, okay, out of that interval. So in this way, you will define exceptions for all those particular cases. And you see, by just seeing the exception name, I will understand, or I will get the solution, or I will understand what was the problem, because they are very specific. So if I'm calling one of your methods from student and you give me back a student wrong age value exception, I think it's obvious that I passed you a wrong value for age. So I should also validate all the values that I'm passing to you. Okay, so that was the idea, to define your own custom exceptions. Okay, so I think we are now prepared to start the unit test part. Once again, we define a separate package for them, tests. Okay, so all our unit tests will be here in tests. Just be sure to save student. Okay, just be sure to save the class, and you can actually close it. So let's add our test case. New JUnit test case. Remember, if you don't see the option here, go to other Java folder and you'll find JUnit test case. Okay. Now, always check which version of JUnit you are using. So I'm for JUnit 4. Okay, always check this. The test case name is called test student. We explained why we are using this pattern, and check all 4 methods. setUpBeforeClass, teardown after class, because we will actually use them today. At least setup and setUpBeforeClass. Okay, so JUnit 4 test student, we are in package tests, and we want to have also the 4 methods. Finish. Okay, now this is like the last step that you need to check, and in this way you actually confirm that you choose JUnit 4, because now it's asking you to add to link the JUnit 4 library. So if you are not seeing here JUnit 4, it means you selected JUnit 3 or Jupyter. Okay, so once again, watch out for the value for the version here. So we have the basic skeleton for a test case with all those 4 methods, which we will use. Last week, we tested them by writing some messages. So we know we start with an initial test, and this is useful because in this way you get a fast reminder regarding how to write unit tests. So we need to have some methods. In order to mark them as tests, we need to use the @test annotation, and this test will always fail. Now, if I want to disable this unit test, so I want to keep it, but I don't want to execute it. Now, let's try to execute it just to be sure that everything is working. So hit run or right-click source, run as JUnit test. Okay. And we should all see one tests have been executed and is failing. Okay, test is failing. If you have any issues at this point, just say, and we will help you. Now, based on the problems showed me by your colleagues yesterday, there is in the latest version of Eclipse, if you are using the latest version of Eclipse, at some point here you have a new file which is called module info, and it's not present in older versions of Eclipse like mine. So that module info can generate some compiler errors if somehow you is not linked with the JUnit library, whatever. So just delete the file. So if you have a module info and you have compiler errors here saying it doesn't know what's this and this, just delete the file. I have seen that solve the problem, the module info. Okay, so if you have any issues, just say something. I will share your screen and we will all look on the problems. Okay, and in this way, everybody will actually learn, because at some point, there is a high chance that anyone will do that mistake. Okay, so how do we remove this test? Okay, it's running, it's a unit test, and it's always failing. Okay, so no added value here, but let's say I just want to keep it for the references. So you have multiple options. You can either delete the @test, but this will actually keep the method, and the method is not a unit test anymore. Now, if you delete the @test and you try to run again this test case, when you right click and choose run as, you will see you don't have the JUnit option. Okay, and if you try to run it from the toolbar button, you'll get this pop-up, no tests found. So what it means this is a method, but it's not a unit test, and we know that because that's the scope of the @test annotation. So why is not okay to do it like this, to disable unit test like this? Because at some point you will forget what was the initial idea with this function. Maybe in 1 month you will see it and you will say, what's with this? it's a unit test, it's a method used by other unit tests, so it's creating confusion. Now, another problem is that if this is really a test and you just want to ignore it for now, for today, and you delete the at test, then maybe tomorrow you will forget to redefine it as a test. So your colleagues, when they will run the unit tests, they will see all the other unit tests here, but not this one. So at some point, they will say to you, hey, you need to implement that unit test. We see that that unit test, particular unit test is missing. So you will forget that you already have implemented it, but you just remove that test. So generally, you will rewrite it. And at some point, you will realize, if that will ever happen, that you already had that test, but you forgot it. So we don't remove the at test. If you just want to remove the unit test, this is the only way to do it. You just delete it, okay? You don't leave it here. And obviously, this will also not work because now we are generating zombie code. Remember the story from clean code. Okay, so how do I keep it, but I want to skip its execution now? So JUnit has introduced, in JUnit 4, they introduced this at ignore. Okay, so if you want to keep your unit tests, but for particular reasons you don't want to execute them, but you still want to see them as unit tests because you don't want to forget them, use this ignore. Now, ignore is defined in org JUnit, so you need to import the org JUnit library. Now, this doesn't exist in JUnit 3 or JUnit Jupyter or 5. Okay, so it's specific to JUnit 4. In JUnit 3, you can command the unit test or remove the test keyword from here, but it's not okay. Okay, now what will happen if you run the unit test? So run as JUnit test. You see you have 1 out of 1 and 1 skipped. You still see the unit test here in the list, but it has this, let's say, disabled icon or ignored icon. Okay, it's a gray icon. So you still see the unit test here. You will not forget it, but for now, the unit test is not executed. Okay, so let's dive into right-BICEP and CORRECT. So the first unit test that we will write will be for right, okay, from right-BICEP, and conformance. Because remember, they are similar. Now, right, it's saying for right values, you should get right results. Great. And conformance is saying the same thing. But conformance is also suggesting that if you don't receive right values, if the values are not conformant, you should throw an exception. So they have a similar perspective, but they cover, let's say, conformance is also covering also exceptions. So this is from CORRECT. Is the first C, correct. Okay, so what do we want to test? We have a constructor, we have some set methods, we have a method that's computing the grades average. So let's try to test all this one. Now, what's the scope of the constructor? So we are using a constructor, for example, this one student here. What's its scope? So what's the job of this constructor? If we want to test it by writing a right or a conformance unit test, we need to test what's right. So what's the job of this constructor? Can you tell me?
To initialize a student.
Okay, so because it has input arguments, its job is to initialize its attributes. Great. And the second scope of a constructor?
To check if the values are right.
Yeah, it should do, but it's not its scope. It's an additional thing to validate the input. So one objective of a constructor like this one with arguments is to initialize the attributes of your object. But what's let's say the scope of any constructor, including the default one?
To make an object.
Exactly, to create an object. So this is the right thing that a constructor should do, to init the attributes of your object and to create it. So let's test these two actions. So the first test that I will write will be to test what your colleague said, to see if the constructor is initializing the attributes of the new object. So at test, public void, test, constructor. We know we are testing the student class. This is the name of the test case. So we test methods from student. It's obvious that that's the constructor from the student class. So public void test constructor, and let's say write init attributes. Okay, so this is a write type constructor in order to check if it's initializing the attributes, okay, or something like this. Okay, so in order to do that, we need to actually call the constructor, because this is the function we want to test. So at this point, we need some default data. We need some default data, so try to initialize my object with that data and want to see if the values have been set by that constructor. So this is the first step, define the test data. So I will define this string initial name equals Bob, okay, int initial age equals 21, and also we need some grades. Array list integer grades, initial grades, if we want to use the same pattern, initial grades, okay, equals new array list, yeah, the first time seeing array list. Okay, we need to import it in order for the IntelliSense to help us. So we have array list initial grades, new array list. Now let's add some initial grades. So initial grades, add 9, and another one, initial grades, add 10. Okay. So we have all these initial variables, name, age, grades. Now let's create the student. Student equals new student, and we pass all these initial values, name, age, so it'll be like initial name, initial age, and initial grades. Okay, now if the constructor is implemented correctly, once again we need to import student. Okay, so if the constructor has been implemented correctly, it means it has created the student, and we will test that in a different test. And our new object, which is the student that we manage here, has these values, initial name, initial age, and grades. So how do we check them? Now, in order to check them, obviously we need to ask the student what's its name, what's its age, and so on, and we need to compare them with our initial values. So it will be like this, assert equals. Now, expected is initial name, and the actual value is student get name. Okay, so in this way we test if the name has been set properly. We do the same thing for age, initial age, and here I will get student get age. Okay, and now for the grades, now you have an assert array equals, which is great because it's checking two arrays based on their values, not their references. But the problem now is we can't use it because we don't have access to the student grades array list. Remember, we didn't generated the get grades, and we have a different way to query each grade. So in this case, in order to check the grades at, let's say, grade value level, we need to do something which is, let's say, similar with a assert array equals. So it will be like this: for int I at 0, I less than grades, initial grades size, initial grades size, I++. And now we assert each grade individually. So it'll be like assert equals. Expected is what? Grades, initial grades. Get at index I. And actual is student. And we will use the get method that we have implemented. Get grade at index I. Okay, now the problem here is that get here returns an integer and this returns an int. So this is returning a reference type. So we need to cast that to an int value, okay, to do the unboxing. Okay, so all these lines will assert if the student data has been properly initialized by the constructor. Next week, we will talk about properties of unit tests. So one property is that each unit test, like any function, should have a single responsibility. A unit test should have a single reason to fail. Now, here you have multiple reasons for this unit test to fail. Okay, so why? Because you have an assert equals here that may fail this one and this one. So if you want to keep that this unit test in line with single responsibility, then you can split this unit test in actually 3 different unit tests. So this will be test constructor write init name. You will write another one, test constructor write init age, and the third one, test constructor write init grades. So in that case, you'll have 3 unit tests which will check different parts of the constructor job, which is to initialize those 3 attributes. Okay, so those unit tests will have a single reason to fail. Okay, and once again, you are in line again with single responsibility. Now, for this example, we may say this is still okay, because here we are actually testing the constructor. So this is like it either doing all the stuff correctly or no. Okay, so we take the constructor as a package. It should do all the initializations right, because if it's not doing any one of them, we consider that the constructor is not correct. Okay, so let's say once again we can go for this approach. Okay, so this is testing the constructor for initializing attributes. Now let's try to test it for its principal scope, which is to create objects. So test public void test, once again constructor. Okay, and it's, let's say, right or conformance. Now we want to see how, if it's creating objects, create objects. Okay, so in this case, we want to do the same thing, to call the constructor with right values. And now the only focus here is to see if the constructor for right values is able to do that. The only reason that the constructor will not give you a reference for an object is that the constructor has thrown an exception. So if the constructor is not throwing an exception, you will always get an object. You can't interrupt the constructor without an exception. So this is the only way to interrupt the constructor, by throwing an exception inside it. So the constructor will be interrupted and it will not deliver the object. Now, for any other cases, when the constructor is finishing without an exception, you will get an object. Now, if that object has or it doesn't have the right values, that's another issue. And for that, we have this test. Okay. But like I said, if you want to test if the constructor works, the main idea is to test if for right values, it's giving you the object. And otherwise, try to expect for an exception, because this is the only reason for a constructor not to create an object. Okay, so once again, I will be tempted to do this. Remember the try to copy paste these values. Okay, so we know what to do because we talked about this last week. So in order to avoid doing this copy paste, because we just realized we need this initial name, initial age, and initial grades, we need these values. We know that we can use the setup method or setUpBeforeClass. So let's take this part. The first 3 lines for test constructor right, init attributes. So let's copy them, Control C. And here, let's define this attribute. So this is like now they are class attributes. Now, initial name, initial age, and initial grades, obviously they are not some attributes that will change in time. They are attributes that they will always keep those values. And each time in any unit test that we need an initial name or an age or grades, we will reuse them. So for that, in order to be sure that they are constant and no one will change them by, I don't know, in other unit tests, let's mark them public static final. And because they are constant, you know, let's name them with caps. So this will be our initial name. This will be public static final int age. Okay, and also we can block this reference to this array list. Okay, and this will be called grades. Okay, so in any unit test or in anywhere here in this test case, if we need some default values for name, age, and grades, we can reuse them, and we can be sure that no one will change them. So they will always be Bob 21 and these grades. Now, where do we initialize the grades with some values? Where do we add some values? We can't write here because we are out of any method. We can't write here grades add. Okay, this is in the class definition section. So we know we have 2 methods, this one and this one, which will be always executed this before all the unit tests and this before each unit test. So which one do you think is more proper to use in order to add some grades here?
Before all the unit tests.
Before all the unit tests, because we need to do this only once, right? So the perfect place for that is here. So grades, add 9, and grades, add 10. Okay, so this is our initial setup. Remember, this is called test fixture. Okay, the collection of resources that we need in our unit tests. This is the name for it. Okay, so we initialize the grades here because we want to do this only once. Okay, that's the idea. And we will just reuse that array list again and again. We know that later we will also need a student, but because this student is used by unit tests, and generally unit tests will try to change something there or call its methods, we don't want to provide it as a static variable, because in that way, the same student will be shared by all unit tests. It's like a global variable, and we want to avoid that. So I want to keep the student as a standard attribute of our test case. Okay. And now the student, because all unit tests, they need to be independent from each other. We don't want to reuse students that have been changed by other unit tests, because in that way, you will never have anything certain about that student. You will never know what's its real name, because all previous unit tests have played with it. So in order to create a new student each time a unit test is executed, we call it here. We create it here in setup. So I have defined class attribute, a student, a reference to a student, and we will initialize it here. And in this way, we know that each time a student will be created for each unit test. So new student, and now I'm using the default variables: name, age, and the grades. Okay. So I start with all those defaults. So each unit test will have this student. Okay, we added these static variables. We defined a student reference. We used the setUpBeforeClass to add some grades in this array list. Okay, and we initialized the student in setup, which is executed each time before a unit test will be executed. Okay, so now, do we need to change test constructor right init attributes? No, because yeah, I can skip this part if you want to refactor it, but I will not do that. But this part is still needed. Why? Because this is a unit test that is checking the constructor. So even if we are creating another student in setup, we want to test the constructor here. So that's why I need this call. And this is shadowing. This will hide, you know, the shadowing problem. It's a local variable to this method, so it's hiding the class attribute, which is okay. So here we are using our student because this is shadowing. Okay, and in this case, it's okay. The local variable has higher priority versus the student. And this is also visible by the color. The name is the color used here to write the variable name. Okay, so now let's go back to the test constructor right create objects. So here we ask this question: if I'm giving you right values, are you giving me an object? So this is the question to the constructor. Okay, so let's test this part. Student equals new student of name. They are right values, so why not reuse them? Once again, I'm explicitly calling the constructor here, and I'm not using the object created in setup because this is the unit test for the constructor. So I need to see the function here. Okay, when you test a function, you need to call the function inside that unit test. This is one rule that you can use to verify your unit tests. So if you write a unit test which is saying I'm checking, assessing the, I don't know, get grades average method, and you are not calling the function there, I don't know what's that unit test is doing, but surely it's not checking that method because you don't call it. Okay, so once again, we explicitly call the constructor here, and now let's see if everything is okay. So if everything is okay, we get a student reference. I don't care which are its values. We have another unit test to check if the constructor is initializing them correctly. Okay, so this is not the purpose of this unit test. Okay, so if here we get a reference which is not null, it's okay. Now, if the constructor has an issue and it will throw an exception, that's not okay because I'm passing you right values. Why are you throwing an exception? So how do we write this test? But here you see, we are not expecting for an exception. We are expecting for an object. So let's be prepared for the bad thing. Maybe the constructor has an issue and is throwing exceptions. even if we pass right values. So here, catch, let's catch any exception. Any exception for us, it's a bad thing, because it will always mean this: fail. The constructor is throwing an exception for right values, which is not okay. Okay, this is what we wanted to test. And if the test reaches this point, it's a failed test because we have a problem here. We are passing right values. What's the issue with that? Okay, now how do we mark the test with success? Here, we know the story with the exceptions, the try-catch mechanism. Remember, if you call this function here and it's throwing an exception, after this point, nothing is executed and the execution continues here. But if this function is not throwing an exception, naturally, the next instruction in line will be executed. And this is the next instruction in line: assert not null, student. So this sounds like this. If I'm passing you right values, are you creating an object for me? I call the constructor with right values. If everything is okay, this should be okay. So we should get a not null reference. And generally you get it if you pass this line. Okay. Now, if something bad happens here, which means we have an issue with the constructor, the execution jumps here. So this will not be executed. Goes here the execution, and we mark the test with fail. Okay. So this is one way of testing if the constructor is doing its job, like giving you objects for right values or initializing the object. So you see we have 2 unit tests for that. And this could be considered 2 right unit tests for constructors. So let's run them. Let's see if our constructor is okay. So right click source, run as JUnit test. And we have 2 green unit tests. Well, we should have 2 green unit tests. Write init and write create objects. Okay, because at this point the constructor is doing its job. Now we have other bugs there, but other principles from right-BICEP and CORRECT will help us identify them. But from this perspective, everything is okay. It seems everything is initialized properly. You get objects. Okay, up to this point. Anyone having anything to add, or is anything unclear, or do you have any questions? Okay.
Sorry.
Yeah.
I think my connection had some problems when you explained why the commentary is right from right bicep and conformance from correct means. Can you tell?
Where here, right from right-BICEP and conformance from correct?
Yes. Why have we written that?
You missed the yesterday course?
Yes.
Okay, so we explained this. So generally, because you have this question, what do we need to test? So generally you will say test for null, test for right values, test for, I don't know, wrong values, strange values. So we can have a debate all day long by trying to make a, let's say, a guide of which values you should use for unit tests. And I think we will not finish it. And sometimes we will miss some values. So in order to have, let's say, a guideline or a common ground for this kind of discussions, what do we need to test, which are the values, we are using these 2 guidelines. And you have the book, the Pragmatic JUnit Testing in Java, okay? And you have 2 chapters there. And they are proposing these 2 acronyms, right-BICEP and CORRECT. And yesterday, and I will provide you the record of the course, also for the Romanian course and English course, where I explain what's each of those criteria. They are actually beacons. It's like, hey, when you try to test for right and conformance, always test with right values, so you will expect right results. Okay?
Okay.
So yeah, those are guidelines that we are using, and they are important because we need to speak the same language. And at the exam, normally we will ask you for a given method to write, let's say, a reference test, unit test. So in that way, you know what we are asking you, and we can evaluate your response, because otherwise it could be very subjective. Okay?
Okay, thank you.
So you can get the book, and until I publish the record, you can read, I think there are 20 pages, both chapters, which are covering right, BICEP, and correct. So you can actually read those chapters in half an hour, and you will get the idea. And after that, you can watch the course. Okay?
Okay, thank you.
Okay, no problem. So if there are any other questions regarding these two unit tests, let's
Why don't we use the expected notation as we did Friday, and we
yeah,
try the
because
try-catch block?
yeah, this is a right test. So in a right test, we expect for what? For an exception or for a right result?
For the right result, but
Yeah. So if you write a unit test which is expecting of an exception, it's expecting an exception, when that unit test will be with success, will be green, when you get the exception or not.
as I recall, expected was with equal, so maybe if it's different, then wrong age
No,
value
you
exception.
can't write expected different than. When you write expected, it's like you sign a contract. For you, being happy means we need to take we need to get an exception.
So can't we write unexpected?
No. There is only expected. Okay, so that's why you see when you write a test with expected, you expect the exception, right? So the test will be success if you get the exception. But here, the exception is the opposite of success for a right test. That's, let's say, the bad thing. That's the reason for marking the test fail. Okay, so unit tests which are expecting for an exception, they are actually testing the error condition. So writing a constructor similar test for bad values and with expected will be like seeing the constructor in a different light. So your colleague is saying, we have seen last week that we can write a unit test that will try to test a method, and it will check if the method is throwing an exception if the values are wrong, right? So let's do this test based on, because this is also something we need to cover today. So if I write here a test, public void test constructor, okay, so if I write in here and expect, the scope of this unit test is to see if the method is throwing an exception, right? So which criteria is this one? For example, in right BICEP, which criteria is for exceptions? Error, conditions, error. Okay, so this is the error conditions from right BICEP. Existence is incorrect. Okay, now in correct, you don't have something that will force you to throw an error condition. It's assimilated with conformance. So it's like conformance, which actually translates here for wrong values, you should, I don't know, throw exceptions. Okay, so it's an interpretation of conformance. That's why should throw exceptions. That's why I was telling you yesterday that actually right, BICEP, and correct, they are complementing each other. Okay, so that's why we need to use both sets of perspectives. Okay, so when you write a unit test for an error condition, you prepare for the worst, which means that's your success if you got the exception. So we have seen that in order to do that, we have the expected attribute for a test. And here we need to pass the type of the exception that we will expect for this unit test. So let's say if I'm giving you wrong values and you are the constructor, what do you should do? What's the proper
exception?
Exactly. So for both exceptions, because a constructor will, let's say, receive multiple data types. Let's go for the generic one. Student bad value exception.class. Okay, so in this case, this unit test constructor bad values. Okay, so or exception, let's be more specific, or bad values error, just to make the link with error conditions, bad values error. Okay, so we need some bad values, right? Because using the normal ones, that will be right conditions, so the constructor should do its job. So in this case, let's choose, I don't know, a wrong age. So let's say wrong age equals minus 23. Maybe a wrong name equals JO. Okay, or just J, because it has less than 3 chars, and so on. Or we can pass also an empty array list, or we can use the the empty array list. Integer, no grades, null. Okay, so they are all wrong values. I think it's obvious for anyone. So in this case, we want to call the constructor and we expect for an exception. So this is the scope of the unit test, to get the exception. And in that way, we are okay. The test is green. Okay, you see, it's different. It's a different perspective. Here, we expect for a student. This is our expectation. This is the thing that we want to get. And here, we say, if the unit test, in this unit test, we don't get the student, that's not okay. So that's why we write the catch and we fail the unit test, because this was not its purpose. I'm giving you right values. So that's why here I'm not using expected, because this unit test has a different goal. It wants to check if the constructor will give you an object for right values. That's the behavior that we want to test, this one here, and not getting the exception. Now, in opposition, if I'm giving you wrong values, then the normal behavior of the constructor should be throw an exception. You can't create me an object with these values. Okay, you see, this is the two difference between when you test the constructor for error conditions and you test it for right conditions. You expect two different results, and you want in the end that the constructor will cover both cases. For wrong values, it should give you objects. For right values, it should give you objects, and for wrong values, it should give you an exception. So let's call the constructor and see what will happen. So student, new student, student, new student, or because we don't expect an object, we can just write new student, whatever. We just call the constructor, and here we are expecting for an exception. So student equals new student of wrong name, wrong age, wrong age. Okay, and no grades. Okay, and you see, if we run this unit test now, run as JUnit, the test is failing. Test constructor bad values error is failing. Why? Because it didn't got this, and this is what we expected here. The other unit test is passing because for right values is giving us the object. So at this point, what do we need to do? We need to fix the constructor. We need to validate age, name, and grades. And for if any of those three values is wrong, it's not valid, we should throw a student bad value exception. So we have this failed test because the constructor is not doing its job from this perspective. So it's clear now the difference between a right unit test and one which is expecting for an exception, and why here, if we get an exception, is not okay, it's fail, but here it's okay. Okay, so do you have any questions here?
Yeah, like normally you shouldn't get like a set of specifications. I mean, for me, it doesn't really make sense, this test of getting all the things right and getting the right example. That's why I'm asking, and that's why I asked.
So what are you feeling is not okay?
Exactly the right part, like testing
This part
things
here,
in.
testing this?
Yeah.
Okay, let me show you how easy it is to do a mistake.
Okay.
If I go into student and write this, I think at any moment in our, let's say, developer's life, we did this mistake. What's this? This is shadowing. Remember, we had a discussion 1 year ago, watch out for this kind of stuff. And generally, if you don't use this, it's normal. So how difficult is to see this error? If you wrote it, it's very difficult. Your subconscious will say, no, the mistake is not there. Now, let's go back here and run again the right unit test. So run as JUnit test. Which test is now failing? Test constructor right init attributes. You see it? Expected 21, but was 0. So it's the unit test now doing its job. It's helping us see this error. Maybe the constructor was not a good candidate. Now, let's write a right unit test for get grades mean to decimals, okay? Because this is something we should write, right? It's not generated. So
I think the only one that I don't agree with was just the constructor.
Yeah, but you see, even here for this constructor which was generated, here we have a shallow copy. And without a reference unit test, you can not see this problem here, which is wrong here. Why? Because you are referencing the external grades. And I'm passing you the array list, and after that I will change it. So I'm changing your grades. So for a reference unit test, that will be valuable. Okay, so yeah, I agree with you. That was a generated method. So now, normally, you should unit test all the methods. And normally, yeah, you may not generate them, or you generate them and after that you change them, okay? Because you just need a head start on writing code. So for example, if I go back here and I write another right or conformance unit test for get average for the method, the last one, get grades mean to decimals, I will write it like this, okay, at test. So public void test, I will get the method name because it's quite long. Okay, so right, okay, which means if I'm passing right values, which means an array with some grades, the function should return their mean with 2 decimals, okay? So in that case, we have a student which is created by setup. So I will reuse that student because I'm interested only in its grades. And once again, we know that we have a grades array defined here and initialized in the setUpBeforeClass. But if you want to use some values in a unit test, you need to have full control over them, which means if I start with the supposition that these are the grades for which I will compute the average, which means the final result should be 9.5. And someone after this moment, or me in 1 month, will change the values here, that test will fail because we expect for 9.5 and the average will not be 9.5 because someone changed these lines here. So in this case, because I want to be independent from any changes that will take place on that section in setUpBeforeClass, I will create my own local array list of grades. So this array list of grades is going to be changed only for this reason. Someone is changing the unit test. So in that case, we'll also update the expected value. So array list integer, let's say new grades, okay, equals to new with new array list. Okay, so now I will add the grades. Let's add something different, like 9, another 9, and a 10. Okay, and a 10. So it's obvious that the expected grade average will be expected average will be 9.33, because remember the scope of the function is to return the average with 2 decimals, exactly 2 decimals. Okay, so now let's get the value, computed average. Now we didn't set these grades for our student, so let's set them, set grades, new grades. Okay, so now the student should have the new grades, 9, 9, 10. Okay, equals student, get grades mean 2 decimals. And now we do the assert. Assert equals. We played last week with floating point values. So here the expected is expected average. Sorry, what's that? No, expected average, computed average. And because we expect for a value with 2 decimals, it means we want 0 errors or margin of error, which means we want exactly the same value here. If the average is computed correctly, it should be 9.33. Okay, so yeah, maybe this makes more sense. And generally, with the exception of constructors, we will generally test all the other methods. Now, the constructor is just one method, but what I wanted to show you is that we can also unit test constructors. But like I said, it's only one function, and after that moment, you focus on all the other functions that you have in your class, like set age, set name. So these are also prone to errors because they don't validate, and for some of them we expect errors and so on.
Yeah,
okay.
but normally you'll have those things in the specifications. Like right now, we don't really have specifications for. Yeah, exactly. But we didn't do anything regarding that. So.
Yeah, but if we go by test-driven development, this is actually the way. You start with some fake dummy implementations. Okay, you write unit tests based on the given specifications. The unit test will fail, most of them, because here you have almost nothing, like here. And after that, you change the function, and the test should be green. So this is actually the way that TDD recommends. Now, in most cases, it's a combination. You start here by writing more than this, and after that, you write unit tests, and maybe the unit test will help you validate that what you have implemented is correct, or maybe they will help you to find some corner cases that you missed, some very strange scenarios. Okay. But the idea of the unit test is to test. Whatever way you choose to implement these methods, to generate them or to write them, the scope of the unit test is to just make you sure that what you have, it's okay, or maybe to show you that you need to do something different. Okay? So just take the unit test as they are. Okay? They just test the methods from different perspectives. Okay, so we need to stop at this moment because the seminar is already over. We will continue next week by trying to check other conditions from right-BICEP and correct. Thank you for your interventions. So this is the way the seminar should be, and also the course.